Quiz 4. Rank the substituents for the starred asymmetric center. Add wedges and dashes to this molecule to give an R stereocenter. Must show your work, right? So for this one, again, moving out one bond at a time. So carbon, 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 carbon. So everybody's tied. Then you got one more bond. Right? What's this carbon bond to? It's bond to a carbon, and a carbon. So carbon, carbon, carbon. What is this carbon bonded to? It's bonded to a carbon, an H, and an H. Right? What is this carbon bonded to? It's bonded to an oxygen, a hydrogen, and a hydrogen. What's this oxygen bonded to? An oxygen, a hydrogen, and a hydrogen. So from this, we see that these two are top, right? And now versus these two, carbon to carbon, that's a tie still. Carbon to hydrogen, that makes this 3. Right? That would make this 4. But now these two are still tied. So oxygen and oxygen, we go out one more bond. So what's this oxygen bonded to? It's bonded to a hydrogen. What's this oxygen bonded to? A carbon. So this wins. So this is 1, 2, 3, 4. So the biggest thing in these rankings, one bond out at a time, right? Don't look, it's not a total thing, right? It's not that as though it's like the high atomic number always wins. It doesn't matter what else is there. Now I do the rankings. What I would do is, right, I got 1, 2, 3, 4. It wants an R, so I grab my molecule, make it into an R. How do I do that? I hold the green ball. The green ball's pointing away from me. And I say red, white, and blue. And if it goes to the right, that's R. So I want to make sure it's an R molecule. And then if I made sure I have an R molecule, I map it onto this, right? So I did my colors, red, white, blue, green. And there's multiple ways to do this. I chose to put white and blue in the plane. So white's pointed up, blue's to my left, and then green should be coming out, and red would be going away, and that would make this R. For this one, for number 2, add lone pairs. So you gotta have lone pairs on everything. Give the curved arrows for each step of the reaction below, and also make sure you're balancing your charges. So you notice you come up with an H+. That's the catalyst. That means it needs to be regenerated at the end. And the overall charge of the starting material is a plus, so you have to maintain that throughout. First step, proton transfer protonate. Oxygen gets protonated. So this is an example. This made, right, OH by itself is not a very good leaving group. But when you protonate it and make water like this is a really good leaving group. So it's a good example of that, making a good leaving group. Or something into a better leaving group. Leaving group leaves. Carbocation. Right? There'll be resonance. So you put the plus charge here. You can number those atoms. That'd be a good idea. Addition. So another way to do addition is when something adds to a carbocation. That's addition as well. Not always just breaking pi bonds. So the solvent adds. Again, balancing the charge. The nitrogen had a methyl, an ethyl, and an H bonded to it. So this H is going to fall off. So the H just falls off. Make sure the arrow of the electrons is correct. It goes to the nitrogen. And when this H falls off, it no longer has any electrons, and you've regenerated H+, which is a deprotonation or proton transfer to regenerate the catalyst. People try to do, right, if I have steps, that means there's steps. You can't do it all in one thing, right? So each of these steps means there's a separate step along the way. Right? So a reaction can have a lot of steps. Overall, this is a SN1 reaction too, if you're thinking about that, right? You're making a carbocation substitution. You're substituting one thing for another. So another thing to think about.